Very good morning, everybody. Let me begin by thanking Ringer for this wonderful opportunity to connect with all of you at 2023 Asian Manufacturing Summit at Jakarta, Indonesia. I really wanted to be present there personally. I attended a Ranger conference like this a year before COVID started, and I really enjoyed the energy in the room. But this time, because of some commitments, I couldn't be there personally. This is a recorded presentation, but I am also here online. So at the end of the presentation, if you have any questions, we can take up that as well. So I'm looking at somewhere around 20 minutes of presentation and then followed by maybe around 10 minutes of question and answer. So my objective is to ensure that by end of this presentation, make you understand how advanced plastic recycling technology can be made cost effective and what is our take on this to make it cost effective and sustainable. So let's start. Little bit about me. I am Suhas Dixit, founder and CEO of APChemi. I'm formally trained in chemistry, chemical engineering, marketing, and contract management at Institute of Chemical Technology, IPER, IIM Ahmedabad. I'm inventor of technology since 2007. I have 12 patents in my name, three granted in India, one in South Africa, and few of the patents are also undergoing positive examinations in Europe, USA, and Canada. My core expertise is in pyrolysis, purification of pyrolysis oil, as well as chemical advanced recycling of end of life plastic waste. About my company, APChemi. APChemi as a company, we are leaders in pyrolysis. We turn non-recyclable plastic, tire, and biomass waste into value. So these are some of the visuals of the projects that we have developed across the world. We have developed 47 pyrolysis plants since 2007 to process plastic, end-of-life plastic waste, biomass, as well as tire waste. We focus on reducing emissions. We are also supported by Shell Petrochemicals through their Shell E4 platform. Earlier this year, we raised $2.4 million of research funds for producing green hydrogen from plastic waste in collaboration with Aalborg University, Denmark. We are working on global projects of capacity up to 240 tons per day of plastic pyrolysis in Europe. We recently completed an engineering assignment for a different client in UK to set up a 42 tons per day of plastic pyrolysis plant. All these projects that we've done, over 47 projects across the world, have created more than 3,000 jobs globally. And recently, our focus has been to produce proof of concept on how you can start with end-of-life plastic waste, like post-consumer plastic waste, empty pesticide containers, multi-layer packaging, non-recyclable mixed plastic waste, and process it through our pyrolysis and oil purification technologies to produce feedstock that can go in for chemical recycling of plastic waste. So these are the kind of proof of concept assignments that our R&D is extremely busy with these days. Our efforts have been recognized by various organizations like KPMG. Last year, we also have won FICCI's Disruptive Circular Technology Award. In addition to that, we are supported by ecosystem of partners, supported by Shell E4, Act Capital, Department of Science and Technology, Government of India. We have a HEC Paris platform at Station F. Technip Energies has given a press release that they want to market our technologies. KPMG is supporting us, Alliance to End Plastic Waste. We are collaborating with medium scale players like River Recycle Finland, as well as players across the world to collaborate and accelerate plastic circularity. And not only with industry, we are collaborating a lot with academia across India, UK, Europe, Australia, and we are open to collaborations with academia across the world to find common ground, find opportunities to accelerate chemical recycling of plastic waste. So now let's get into the technical part of the presentation. When we look at the different types of plastics that are available, the only recycling that is happening these days is mechanical recycling, really. Around 10% of plastic that is recycled through mechanical recycling, except that PET has somewhere around 80 to 95% of recycling rates, depending on whether you count for child labor or not. So if you don't worry about child labor, PET actually has recycling rates of like almost 90-95% in India. If you discount the child labor, then it probably is somewhere around 80%. Similar are the problems across most of the parts of Asia, Africa, and South America. But polyethylene terephthalate chemical recycling is not really a problem to be solved. That problem has been solved. The problem that is to be solved is for mixed plastic waste of HDP, PVC, LDP, PE, polystyrene, and non-polyolefinic plastics. When all of this gets mixed, that kind of plastic waste is not recycled. 90% of that. And you can do downcycling by doing compression molding, by making, say, school benches or doors out of this. But this compression molding business is not really scalable. I mean, there's a limit to how many school benches can we make or doors can we make. And then final option that we have to fall upon is chemical recycling of plastic waste, which has two options. You can do pyrolysis or gasification. Based on the factual data, pyrolysis has much wider acceptance across the world compared to gasification. Gasification in very few use cases can become sustainable, especially if the refinery has a gasifier and that gasifier can take plastic from nearby around maybe 200 kilometers away. But apart from these special situations, pyrolysis tends to be far more straightforward, dependable, and predictable option compared to gasification. In case of gasification, you have to take plastic, convert it into syngas, convert syngas into alcohol, and then convert alcohol into a feedstock that can go into refinery. So it's much longer process compared to pyrolysis and oil purification, which is far more straightforward and predictable as such. This is where we specialize as a company. Now, when we start discussions of chemical recycling, we need to be convinced why we should do chemical recycling. And we look at big picture. Less than 10% of 350 million metric tons of plastic waste is recycled. Rest of the plastic waste is going to landfill, environment, and incineration. Uh, Currently, around 350 million metric tons per annum of waste is generated, which will increase to around 450 million metric tons per annum by 2030. Right now, around 100 million metric tons per annum of plastic waste is going for burning, which will increase to somewhere around 150 million metric tons per annum by 2030. And we shouldn't really burn plastic if we can chemically recycle it. Now, if we combine the chemical recycling ambitions of all five global petrochemical companies mentioned here, based on the public data, they would together would have ambitions of chemically recycling, let us say, 10 million metric tons per annum of plastic waste. But still, there is a huge gap between the current ambitions as and compared to how much we are going to burn and send to landfill, fires and all. So this is one of the reasons why scaling up of chemical recycling is necessary to substitute burning of plastic waste for sure. Burning of plastic waste right now every year generates 300 million metric tons per annum of carbon dioxide footprint. Plastic gets burned in incineration plants as well as landfill fires. Now, from now to 2023, humanity will burn additional 1.2 billion tons of plastic waste, resulting into 3.5 billion tons of carbon dioxide emission, which is a huge contribution to global warming. We don't realize how plastic is contributing to global warming. Now, to make progress on these challenges, a lot of legislations are driving the industry growth of chemical recycling. And as is the case, Europe tends to be mother of all legislations. First environmental legislations come in Europe, and then they get adopted across the world. So, extended producer responsibility came in Europe, and then it got adopted across the world. Similarly, plastic tax has come in Europe, and now a couple of countries in Australia have adopted plastic tax, and plastic tax is being discussed amongst the policymakers and legislators across the world in each country. Carbon footprint tax will prevent the plastic waste going into the incineration plant. It'll prevent it from getting burned in landfills. And legislations like European circularity targets, recycled content targets are getting copied across the world. Like India now has very clear targets for recycling, very clear targets for recycled content. So these legislations are coming up across the world, and that's what is driving the growth of this particular industry. Now, getting a little more technical, the core problem is poor quality of pyrolysis oil that disables chemical recycling. When you take mixed plastic waste, multi-layer packaging, having polyvinyl chloride, polyvinyl dichloride, polyethylene, polyurethane, rubber, soil, and metal, you take that plastic waste and convert it into pyrolysis oil using conventional technologies. What you get is a bad quality pyrolysis oil, which has chlorine, bromine, acid, sulfur, silica, oxygen, nitrogen, metal, heavy metal, and all these impurities cause problem for refineries and petrochemicals. So nobody wants to really buy this kind of pyrolysis oil. Now, to solve this problem, what we figured out is that APChemi can take mixed plastic waste into its technology, or we can take contaminated pyrolysis oil as a feedstock and produce purified pyrolysis oil, which can be used by petrochemical and refinery for production of circular plastics and sustainable chemicals. So if you have to look at a block flow diagram of chemical recycling process, this is how it will look like. So you start with post-consumer plastic waste, uh, which is not recyclable. Either you take non-recyclable plastic waste, push it through APChemi technology and produce purified pyrolysis oil, or you take contaminated pyrolysis oil, push it through our technology and produce purified pyrolysis oil. And this purified pyrolysis oil is a good feedstock to substitute crude oil sourced feedstock and produce circular plastics and sustainable chemicals out of it. So that those sustainable chemicals and circular like sustainable chemicals, example being say linear alkyl benzene, which has a carbon chain length of less than C14. If anything is less than C14, it tends to be biodegradable, so that it's sustainable. So produce circular plastics or sustainable chemicals which can be used by FMCG in packaging to supply it to the consumers, and this is how your carbon is chemically recycled. What our technology does is removes the contaminants from the pyrolysis oil or plastic waste and produces purified oil, which can be used in the existing refinery and petrochemical assets. Uh, these are some colors on pyrolysis oil purification technology of APChemi, how it performs. So we've been able to remove up to 99.7% of chlorine impurities, 99% of oxygen, 98% of bromine, nitrogen up to 73%, and then other impurities as well. Now, the core problem is halogens. You can say 70-80% importance you can give to chlorine and bromine impurities put together, because these impurities are also corrosive. Once you knock out the corrosives, then you can do something with that kind of a raw material in the process plant. So, our oil purification technology always reduces the chlorine content from around 2000 to 4000 ppm to less than 250 ppm to less than 100 ppm. And once we get it to less than anything less than 200 ppm, then you can profitably use adsorbents to further polish the pyrolysis oil and put it into a refinery complex. So what we do is that we remove major amount of the impurities so that use of adsorbents becomes commercially viable, and then this oil can be chemically recycled as a raw material into the refinery and petrochemicals. We have validated our technologies and proof of concept. We supplied oil samples. We've been working with global petrochemical and FMCG companies, and we've received 8 written letters of intent for oil offtake from global petrochemical and FMCG companies. Our cost-effective APChemi technologies can be classified into pyrolysis technology and pyrolysis oil purification technology. So pyrolysis oil technology that we have is highly energy efficient. It is safe. We have zero accident history, even though we have done 47 projects. We have very high tolerance for metal and stones. The input to our pyrolysis projects is flexible. Input can be adjusted anywhere between plastic, tire, and biomass based on the market availability of these raw materials. We've developed 47 projects that have processed 179 million kilograms of plastic, over 1.3 million hours of operation. So there's a fantastic track record to our technology as well. Pyrolysis plants that we have developed have around 330 working days of uptime per year, and we've got 5 patents in pyrolysis. Now, pyrolysis technology very well complements with our pyrolysis oil purification technology. Because we have pyrolysis oil purification technology, we don't need very great quality feedstock for pyrolysis. We can start with a contaminated feedstock, get contaminated pyrolysis oil, but still purify it using our oil purification technology. So that's the advantage. You can use wider variety of feedstock for pyrolysis because you have pyrolysis oil purification technology downstream. So our oil purification technology is highly energy efficient. It minimizes the use of chemicals, and this high energy efficiency and lower usage of chemical actually reduces the scope 2 and scope 3 emissions. We thereby also reduce the cost of purification of pyrolysis oil. We remove corrosives and catalyst poisons that can affect the operations of downstream partner, and has oil purification technology has 340 days per year of uptime, and we've got 7 patents in it. Now, whenever we think of a technology and selection of technology, one of the important things that we have to look at is what is the carbon footprint. So this is the slide which shows you how APChemi technologies reduce emission by 50 to 75% and enable low carbon circularity for food and pharma grade packaging. So many times chemical recycling, the moment we say chemicals, people are a little scared whether chemicals is really good for environment or not. But you have to always compare to what. So if you compare chemical recycling to burning the plastic waste in incineration plant, or burning the plastic waste in landfill fire, chemical recycling via our technologies has much lower carbon footprint. So if you look at kilograms of carbon dioxide per metric ton of end product produced, our technologies has around 20% lesser carbon footprint compared to producing plastics via conventional pyrolysis technology. So compared to conventional pyrolysis technologies, our technology enables plastic circularity at around 20% lesser carbon footprint. And plastic production from crude oil has around 10-15% more carbon footprint compared to our technologies for chemical recycling. We are able to reduce the carbon footprint because our technologies reduce the use of chemicals. We figured out how to minimize the use of chemicals in oil purification, also increase the energy efficiency of these processes. Now, we can produce certain other chemicals from plastic waste that we can discuss across a non-disclosure agreement. Now, just for disclaimer, the feedstock from mechanical recycling can never be used for chemical recycling. If you see say 99% of pyrolysis plants across the world, they process end of life plastic that cannot go for mechanical recycling. So chemical recycling can never afford a feedstock that can go for mechanical recycling for commercial reasons. So chemical recycling would never take feedstock away from mechanical recycling, but just for comparison purposes, the carbon footprint of chemical recycling is not very different from the carbon footprint of mechanical recycling, and these two technologies have very similar carbon footprint as such. So it's not that bad. Chemical recycling as a word might not sound so appealing, but then as from carbon footprint perspective, it's not that bad compared to other options. And our technology is able to even further reduce the carbon footprint of chemical recycling by around 20% by reducing the use of chemicals. Now, this is the second last slide, and even though this is not a technical slide, this is very much a practical slide, and this is the reality of our world. Um, if you see 99% of investments in plastic waste management in chemical recycling projects are happening in USA, Canada, Europe, and Australia put together. But where is the plastic waste mismanagement? The center of mismanagement of plastic waste is Africa and Asia put together. So there is a huge amount of disconnect between where the investments are happening and where the mismanagement of plastic waste is there. Where is the need for chemical recycling? And this global challenge, it really demands for collaborative fundraise effort. We should come together. We as as a technology and engineering and equipment company, we are very keen to collaborate with plastic collectors, city councils, contractors of municipal corporation, petrochemical companies, FMCG companies, packaging companies, investor community, and start developing proof of concept that, okay, how it can be made viable. Can we do prove this at R&D scale? Can we scale it up a little bit? Can we demonstrate using our existing assets that we have by processing certain qualities of plastic waste? And how can we develop a proof of concept that we can start with bad quality plastic that is going for incineration, landfill fire, and landfilling, and come up with a very good quality of oil that petrochemical company can start producing circular plastics. Of course, petrochemical companies would sell chemically recycled circular plastics at somewhere around 30 to 50%, or in some cases even 70% higher royalty than the base price of polymer. But that will also support the entire chemical recycling value chain. So all of us have to come together and collaboratively develop projects so that this mismanagement of plastic waste in Asia is a serious concern, and it needs to be addressed. We can do it together. So once again, I thank Ranger for this opportunity, and feel free to get in touch with me. But even before that, I think we have a few minutes now for question and answer. Even though this is a recorded presentation, I am available online, and I'll be happy to take up some questions and really interact with you. Once again, thank you so much for this opportunity to connect with all of you. And I'm looking forward to being there in person at the next event. Thank you. Thank you.
I very appreciate the whole explanation that you are talking about. I agree with you that the chemical recycling is the only good solution for especially for polyolympic. For example, here in Indonesia, we are already having three companies that's already making recycling for polyester or PET, but
Yeah.
the
Yeah.
polyolefin, I believe, not really. I know that Unilever may be having some venture in that, but it's not really successful. So the chemical recycling again.
Mhm.
According to my information that I got, for the time being, for the upcycling of these flexible packaging, definitely the only solution is the chemical recycling. But the challenge is regarding the cost. The cost. So
Hmm.
From your presentation that this morning that you're working mostly with the eight giant petrochemicals, and
Hmm.
that seems to me that that is the only way that you can really going forward with the chemical recycling technology. So
Hmm.
that's why my question, according to your experience in India, maybe, do you think that in the future that the chemical recycling really can be, let's say, in terms of economy of scale, that you are able then to replace the whole fossil-based resources that we're still using a lot now. And if we are talking about the giant of petrochemicals, of course, they will really try to balance between according to the raw resources or the recycled resources based on the cost. And at the time being, of course, the cost of the recycled is still higher, especially in this moment where the raw material, the raw feedstock is much lower in price. What do you think in the future? What is the solution in the future in that case in order that chemical recycling can really going forward, going upwards? Thank you.
Thank you. It's a very interesting question, and um answer would involve like whether the question is whether chemical recycling would be scalable in future, and can it really substitute plastics from crude oil. Um, so it depends on multiple factors. The first factor is the price of the crude oil. If the price of crude oil is going to be very high, that's really great for chemical recycling. But even if the price of crude oil remains somewhere around, say, $70 per barrel, that offers some kind of stability for chemical recycling. If price of crude oil goes to 30, $40 per barrel, that then there will be a lot of motivation for petrochemical companies to use crude oil based feedstock rather than chemically recycled feedstock. So price of crude oil is one factor. Another factor is uh, legislations. So legislations like extended producer responsibilities are helpful, but it's not really enforceable. The moment you come up with a legislation that includes the term tax in it, that's really enforceable, because uh, uh, not filing correct taxes is a very huge offense compared to not doing some amount of your extended producer responsibility. So the moment you call it plastic tax rather than plastic EPR, the amount of accountability increases a lot. So wherever plastic tax comes up, their chemical recycling will very fast become mainstream process of dealing with most of the plastic waste, because most of the plastic waste is not mechanically recyclable. So plastic tax is something that would also help. And the third factor that would help is cross value chain collaboration. Cross value chain collaboration, which really doesn't exist these days. Cross value chain collaborations means consumers don't segregate the plastic waste. They don't worry much about plastic segregation facilities. Plastic segregation facilities are not designed to provide a quality feedstock for pyrolysis plants. Pyrolysis plants don't know how to purify the oil. Petrochemical companies don't talk openly with pyrolysis companies that, okay, this is the exact specification of oil that we need. There's no open, publicly available specification of oil that is available. Petrochemical companies want to keep larger amount of profits by selling recycled plastic and pass on minimum amount of that to the pyrolysis company. So there's good amount of disconnect between pyrolysis and petrochemical industry. Once petrochemical industry produces polymers and it sends to packaging and FMCG, packaging and FMCG wants to create a packaging that can impress the consumers, and that makes packaging complicated. They mix polyethylene terephthalate, PVC in, and make mixed multi-layer packaging, which is not that straightforward for chemical recycling. That's where our oil purification technologies help. But again, so there's a good amount of cross value chain disconnect between the consumer, the pyrolysis companies, even city councils, contractors of municipal corporations, FMCG, petrochemical company. These are all stakeholders in the chemical recycling of plastic waste, and they are not talking to each other. So platforms like Ringer help us, all of us, to come together and figure a solution out, which is great. So it's a also like last factor is that one thing that we have to understand is that chemical recycling ultimately is a chemical process plant, and chemical process plant should be de-risked in less than 30% of capex. In case one is not able to de-risk the chemical process plant in less than 30% of capex, then probably they don't know how to set up these kind of plants. So you have to go through the substantial amount of planning by developing a proof of concept, observing the reaction at an R&D scale, developing a proof of concept, getting oil quality approved by a petrochemical company, and having a long-term contract at a stable price. So a lot of planning and de-risking is required in initial planning phase. The projects that don't go through that necessary planning and de-risking will suffer financially later on. So these are the multiple factors. Chemical recycling is, as you mentioned, is not a mainstream industry right now, and these factors, all of us working together on this, would probably make this. Uh, I mean, polyethylene terephthalate chemical recycling has reached 95% efficiency now. So polyolefin waste also can reach 80, 90, 95%, but then it also depends on all industry players and legislations coming together. Yeah.